Hello, and welcome to this episode of Madison's Chemistry. Today I'm going to be going over my tips on how to find the pH of salts. So, when I'm approaching a problem that's asking me for the pH of salt, normally what I try to remember is first, if we have spectator ions, so this is something like Na, Cl, Br, etc., there's no contribution to the pH. Right? So if we think, remember, this comes from something like NaOH, this comes from something like HCl, this comes from HBr, so technically it is the anion. These are the anions of a strong base. This is the cation, strong acid. This is the cation of a strong base, right? So if it's coming from anything that's like strong, really, it's not going to contribute to the pH at all, right? So if I see any of these ions, I know right away that it's not going to contribute at all to the pH. Also, some ones that might disguise itself a little bit is HNO3. We know this is a strong acid, so this has no contribution to the pH. And same with H2SO4, right? This ion won't have any contribution, so that's SO4 2-. So just kind of keep a lookout for that. So if it normally goes with a strong acid or a strong base, we know it's not going to contribute to the pH at all, and we can just ignore it. So the easiest one to know the pH of is a strong acid, strong base salt. So that would be something like NaNO3. So right away, I know that this has no contribution because it comes from the strong base, and this has no contribution because it comes from a strong acid. So together, our pH equals 7 because it's only going to be affected by the pH normally of water. So we can just say that the pH is 7. So that's kind of why I like to think of these as having no effect, because if it has no effect, it'll just be totally neutral and it'll give us a pH equal to that of water. Okay, so now let's go over weak acid, strong base. So let's say we have the conjugate from something that's normally a weak acid. So let's say it's F, and let's say it's Na. So this, okay, so first of all, this has no effect. And this is the only thing that has an effect. And F minus is a base. If we put it in water, it will form a little bit of OH minus, right? So it will be basic. So this, we can just ignore this. This will have effect on pH, so therefore this will give us a basic salt. Now let's do the opposite. Let's say that we have a cation that's normally from a weak base, something like ammonium. And let's say that we have an anion of a weak acid. So this, we know right away, it has no effect on pH, so we can ignore it. So the only thing that's affecting our solution right now is NH4+. And NH4+ in solution, it is a weak acid, so it'll go form NH3 and H3O+. So therefore, it's acidic. This salt will be acidic. Okay, so now go ahead and try some on your own. Let's see, we could do okay, so let's just do those two on our own. Oh, maybe you could do K. Okay, so go ahead and pause and take a second to do this on your own, and then I'll go over the solution in just a second. Okay, so this has no effect. This is a base, so this will be basic. This has no effect. This is an acid. This will be acidic. This has no effect, and this has no effect. So it's neutral. pH is 7. Okay, so I hope this video was helpful and that now you feel pretty prepared to look at any sort of salt and determine whether it would be acidic, basic, or neutral. If you like this video, please share it with someone you know, And if you want to stay updated, I will be posting videos every week for Gen Chem 2 topics. So that'd be awesome if you could subscribe. Thank you.